My name's Eric Gross. I'm with the Tech Academy, and you are here, hopefully, if you come to the right place, for the Intro to JavaScript class that we're delivering today. I want to thank all of you for attending. Super appreciate it. This is me. I'm Eric Gross, co-founder of the Tech Academy. I've been a nerd my whole life, computer programmer for decades. I'm a U.S. military veteran, spent 6 years in the Navy in what's called the nuclear power program, actually operated nuclear reactors at the age of 20. I have no idea why the government trusted me with that, but they did. And that's where I also found out that I love teaching, taught electronics, computers, nuclear power, a bunch of engineering stuff. So that's enough about me. And yes, I usually do smile like this, especially when the San Francisco 49ers win. That's when I really smile. All right, so in this class, a couple quick rules. We do have a class assistant. You'll see her in the chat as Regina. She is there to help run the chat, answer questions. Also, although it rarely happens, to boot any troublesome students so that the rest of you can have a really good experience. So please be just courteous, be courteous to everybody. One thing I want to point out is that we're going to be doing coding here. We've attempted to make it as simple and easy to follow as possible. You may be challenged as you go through it. We're here to answer questions. But with some of these things, you're stretching yourself and learning new ways of thinking and learning new concepts, which is probably why you're here, is to be challenged to learn things. One thing I want to stress right now is that when we get to the writing code part, which we're going to do very shortly, make sure you pay as much attention as you can to exactly what I'm writing, and you write your code to be exactly what you see on the screen. One of the things about computer programs, actually about computers specifically, is that they are very precise machines. And especially when you're writing a program, there are certain rules about the exact way you write things that if you don't obey them, your computer program doesn't work. So you just write the code exactly as I have. A misspelled word or a missing symbol, even something capitalized that shouldn't be, can make your program not work correctly. And finally, make sure you're in a distraction-free setting. You want to devote as much of your mental attention to this as you can and focus on the class so that I don't lose you. We're going to try to guide you through some really cool learnings tonight. All right, so we do use chat here. Shouldn't be a shock. And if you're, have any questions about chat, here's some specific quick instructions on the screen. For right now, what I'd like everybody to do is to go into chat, find me, Eric Gross, and just put in the chat who you are and where you're from. Where are you joining us from on this fine evening or morning or whatever it happens to be? So let me look at chat here and see if, awesome, Matt's coming in from Colorado. Got people from Florida. Richmond, VA, awesome. Excellent. Nate Brink, one of our students from Seattle. San Francisco Bay Area, that is my hometown. I was born in San Francisco and raised up north there in Mendocino. Matt is here from Germany. That's fantastic, man. Welcome. Destiny from Washington State. You were on our class just a couple days ago. It's good to see you. Hood River, Oregon. There's a beautiful, beautiful place. Wow, we got people from all over the place. This is fantastic. Good. Well, thank you all for attending. Super appreciate it. And obviously, I think we're all good on using the chat. All right, so what's the agenda tonight? Well, we're going to have a short intro to the Tech Academy. Make that very, very brief. We're here to teach you. And we're going to do that. We're going to write code. You're going to get your hands dirty writing code. And we're going to use the process of writing code to teach you the basic elements of any computer program. And this will help you learn any programming thing you want to do in the future. We'll have a brief Q&A after we've done that. And then we'll cover some data about our coding boot camps. And at the end, if you stick around, we'll give you a free gift. It's a really cool one. And by the way, please do stick around because one, we'll give you the full copy of the program we're going to build, just in case you want to be able to tweak it and have fun with it and experiment. And like I said, there's a free gift. All right. By the way, this free gift is a brand new one we haven't given out in any of our free coding classes. So I think you'll really enjoy it. So a quick thing about the Tech Academy, who we are. We provide coding boot camps. The coding boot camp is an intensive training process designed to rapidly create a technology professional. They started about 11 years ago, 12 years ago, the summer of 2012, We were one of the first coding boot camps in the country. We were founded in 2014, and we provide, and this is really important, cost-effective programs, but maybe even more important, they are self-paced online certification programs. In our programs, you move at your pace. You don't have to move along with everybody else, which is great. We also focus on what the technology industry really needs in its new talent. We focus on in-demand skills so that your technology career can get started right away. We also focus on the fundamentals so you have a long career ahead of you. More on that later. In terms of our tuition, the average tuition for boot camps, at least in America, is about $13,500 for a good coding boot camp. Considering what you get paid when you move into the technology industry, even at $13,500, a decent boot camp would be a fair price to pay. We are priced well under the industry average. In fact, we even have boot camps starting at $5,300. And finally, I just want to cover what the mission statement of our school is. Our mission at the Tech Academy is to graduate entry-level technology professionals that excel in the basics of their field and thereafter have successful careers in the tech industry and whose actions raise industry standards and surpass client expectations. What we're all about is getting you working in tech. All right, so let's move on. By the way, if you're curious about the school, you can go to this link, learncodinganywhere.com/Eric. That's ERIK, which is the absolute correct way to spell Eric. And just fill out the contact form in there. It's really brief, and you can learn more about our school. I'll give you, anybody who's interested in that, a minute here to go to that link, which should be in the chat right now, and fill out that form. And meanwhile, I can catch a glass of water because I talk a lot. I love that we have people from all over the country, and in fact, some people outside of America. It's wonderful. All right. So let's go ahead and move on. Okay, so we're going to cover some basic definitions here just to orient everybody to some of the fundamentals. We're talking about creating computer programs, and programs are written instructions. They're created by you as a technology professional. They're written instructions that you enter into the computer, and they make the computer perform specific tasks. Now, one thing I stress in all these classes is the fundamental purpose of a computer. And the purpose of a computer is to take data in, process that data in some manner, and send data on. That's the purpose. Take data in, work with the data, send the data on. So as a programmer, when you're writing programs, those programs are designed to do those three things: receive some data, work with the data, and then send the data on. I know it's rather simplistic, but it happens to be true. That's the purpose of a computer. So if we have these instructions, you need to write them in some sort of written form. That's what a programming language is. It's an organized system of words and phrases and symbols, and they let you communicate with the computer. They let you tell the computer what to do. We use programming languages to create computer programs. For the most part, programming languages read like English. They aren't the English language, but they use all the English language words that you're pretty familiar with. So as a verb, coding is actually doing this, actually entering the instructions into the computer so you can make them perform various actions. So code is the instructions themselves that you write. Coding is the action of writing those things. And we're going to do coding tonight. The language we're going to use, the programming language, is called JavaScript. It's a really popular computer programming language. It's been around for almost 30 years. The birth of the web, as we know it, was around 93, 94. And very quickly after the web started to be popular, we found that we needed a computer programming language that was dedicated to the web. Now, JavaScript has moved way beyond the web. You can use it to create full-blown computer programs, but it's still used for the original purpose, to add functionality to websites. And you'll see some of that in the work we do tonight. Another language that we're going to look at tonight, in a little bit of detail, but not a lot, just enough to get you oriented, is HTML. It stands for Hypertext text markup language. This is the language that web pages are made out of. It's a language that describes for a web page the appearance of it. It affects the content of it. It affects the behavior. That's what HTML is all about. What's on the actual page. So HTML is about what's on the page and the way it looks. And JavaScript is about adding functionality to that, ways you can interact with the web page. And finally, there's another language called CSS. It stands for Cascading Style Sheets. This is yet another language that we use to control the appearance of the text, images, video on web pages. And what's cool about this is it lets you define rules about the way you want your web pages to look in one place, and it can apply to every web page on your site. So it makes it a lot easier to run complex websites. So those are the languages you'll see tonight. As you saw in the description of the class, we're going to teach you basic JavaScript tonight. Now, this next thing I'm going to go over, those of you who are frequent visitors to these classes will have seen it, is probably the most important thing that we could teach you tonight. These are the 5 elements of any computer program. Regardless of what programming languages you're using, a computer program will have these 5 elements. The first one is an entrance point to the program. If we're entering in a bunch of instructions to a program, there needs to be a very first one. Think about this. When you go onto your computer and you want to run, say, Microsoft Word, you'll go find the icon from Microsoft Word and you'll double click on that icon. There are other ways to start the computer program, but let's just accept that one. You double click on that icon. Well, what happens exactly when you double click on it? The computer goes to what is the first instruction in Microsoft Word, which is just a computer program, and it starts right there. And then it keeps on going through, but there needs to be, where do I start? Where do I, as the computer, start if you're telling me to run a program? The next element of a computer program is control and branching instructions. These are the instructions, the computer language instructions, that will affect the flow of execution. In other words, what gets done based on different conditions, based on a decision that's made. To use common English languages, this is if, then, else kind of logic. If age is greater than 21, then print out, you are allowed to buy alcohol. Else, print out, sorry, you can't buy alcohol. I know it's a rather rough and tumble sort of description of it, but this is the logic that we're talking about with control and branching instructions. Without these, a computer program is a very limited use. So you'll find this is a basic element of a computer program. The third basic element of a computer program are what are called variables. These are pieces of data that a computer program uses that can change as your computer program runs. Say, for example, you have a computer program that tracks the number of students in a class. You got the computer program running and you add a student to the class. Well, you need to be able to keep track of how many students are in the class, so you need a variable that will hold that information. Without that, you'd have a fixed number of students in the class. You'd have to build a program that was only able to handle X number of students, say 20. But what if you have more? What if you have less? You need variables. The fourth element of a computer program are what are called subprograms. And this is fun. You're going to make some of these tonight. In fact, you're going to work on all of these tonight. A subprogram is a program within a program, like Inception. What we're looking at here is that if there are a certain set of instructions that you've created that you find yourself using over and over again in your program, instead of typing them out over and over again, you'd actually take them and put them in a separate little thing called a subprogram. And then every time you needed that series of instructions to occur, you would just use that subprogram. And that gives you a lot of advantages, which we'll get into in a little bit of detail later on. Finally, the fifth element of any computer program is there needs to be an exit. There needs to be a final instruction. The primary reason this is important is that while your computer program is running, your operating system, like Windows or Mac OS or Linux, while your computer program is running, your operating system is doing a lot of things for your computer program. It's providing it access to your files and folders. It's managing data storage for your computer program. A lot of little things behind the scenes. When your computer program is done, Your operating system needs to know that so it can stop doing those things and work with other programs. So in front of you, you have one of the more important elements of any technologist's educational journey, the 5 elements of a computer program. And you're going to be building all of these tonight in JavaScript. All right, now we're about to code, but to do that, we need a place to write our code. And we do that in what's called a code editor. You're going to see this link posted in chat. I want you all to go ahead and grab that link. I'm going to open it up myself. I'm going to pull it over here where you can all see it. So I'm going to give everybody a moment to grab that link, click on it, and go to this same site. If you run into any problems, just go and throw Regina a message in chat, and we'll do whatever we can to help you. All right, so don't do anything in this yet. The first thing I want you all to help you all set up is hopefully the ability to see side by side my instructions when I work in the code editor and your instructions when you work in the code editor. So I'd like you, if you can, to set up a side by side system. As an example, if I go to the top of my window, click and drag and move it over to the side, it'll take up half the screen. And then I will do this. I will just pick another screen like this one. You can see 2 things side by side. What you should choose on the left is the zoom application so that I'm on the left and you're on the right. I'll give everybody a moment to do that. If you run into a problem with it, just switch back and forth between windows, but ideally you can see me side by side with you. Give everybody a moment to do that. All right, now I'm going to load up my code editor. I've got it in front of me. Now, I'm going to show you all the computer program that we're going to build today. Don't try to follow along with anything that I'm doing yet, okay? All this code is the computer program that we're going to run today. It is a snake game. Don't worry about looking at any detail here. You're going to get plenty of time to go through this and start to understand some stuff. But right now, I'm going to run that program. And notice over here, I have a snake that's running around on a board. I can use my arrow keys to control the snake trying to eat fruit. When I do eat fruit, my snake gets bigger. Oh man, I'm doing all right. Okay, so this is the game you're going to learn how to play. Bam. Okay, got it. All right, I'm just going to leave that up there and the snake can just run around and run around and run around. Okay, so this is the game we're going to play, or we're going to learn, right? And you guys will actually learn your fundamentals, the 5 basic elements of programming. You'll learn those in JavaScript, and then you'll all get the code for this, and we'll go through it so you can understand what's occurring. So here's the next thing that we need to do. We need to set up us being able to write real simple basic code to illustrate those 5 basic elements. So what I want you to do is go to the link that Regina is going to post in the screen, on the screen, okay? And when we look at that link, you're going to find a little chunk of code. Just copy all of that code, and like I did, paste it into your code editor. You can see it on my screen. I'll give everybody about 30 seconds to click on that link, copy all of the contents of it, and paste it in the left-hand side of your code editor, which is where our computer programming language is written. And then I'll explain what we're looking at. All right. So a couple things I want to orient you to here. This whole tool, this page that you're looking at, because this is a web page, clearly, is a cool little utility provided by the website W3 Schools. What we have here is On the left, a place where you can write code. And on the right is the output of that code. Now, we're going to be writing code in JavaScript. There isn't any JavaScript on the page in the code editor over here yet. The only language that's on the code, in the code editor right now is the language called HTML, which shouldn't be a shock to you because it even says HTML. If you wanted to make web pages, this is what the language to make web pages looks like. And you can even see that it's got content. If you run it, over on the other side, you'll see my heading. You can even change that and put in, say, an exclamation point. Try that, put an exclamation point after my heading and hit run. And all of a sudden you see it change on the right. Now, this part is super important. We're about to put some actual JavaScript into our code editor. The place we're going to put it is in this large area in between this script and slash script. These are called tags, by the way. That's an HTML thing. And inside those tags, we're going to write some JavaScript code. Now, that code is going to be turned into instructions that your computer can understand. This is something we're not going to get into a bunch of detail with in this class, but your computer doesn't operate on words that look like English. It operates on instructions that are written in this really cool language called binary. And you'll learn all about this stuff in our boot camps. But here's the big picture is we need something that can read through the code you're about to write and actually execute it. And the something that does that is your browser. I don't know what browser you're using. It doesn't matter. I'm on Chrome. You could be on Safari. You could be on, Firefox. If you're really unfortunate, you're in Microsoft Edge. But no matter what, you have a browser. Browsers are capable of running JavaScript computer programs. And because they are, what many of you may not know yet is there's a bunch of tools inside the browser for you to use when you do computer programming. They're called dev tools or developer tools. Every major browser has these, and I'm going to show you where they are because we need to use one of those tools. So pay very close attention here. Over in this code editor on the left, I need you to right click and you'll see something like inspect or see source or developer tools. On most browsers, it's inspect. When you click on inspect, all of a sudden, something appears on the right-hand side of the screen. These are the developer tools. I will drag mine over so you can see a lot more detail. Don't get overwhelmed by all this. You're only going to use one thing inside all of these developer tools. But it is kind of cool. What you're looking at is a peek under the hood of everything that's going on with the web page you're looking at. There's a lot of learning that can be done just by accessing these developer tools. But again, we only care about one of them. Look at the top of whatever opened up for you, and you should see a bunch of things like you see here: elements, console, sources, network. You should see very similar tabs somewhere in your developer tools. Click on the console one. That's all we care about is the console. I'm going to give everybody a moment to do that. All right, now let me explain what we're looking at. A software programmer who's working on web pages needs a place behind the scenes where they can have helpful messages come out of your computer program. That's what the console is. They're not seen by the users of the web page. They're only seen by developers. And right now, you are a developer. So let me show you how this works. Again, pay close attention. Over in the left, click in between the script and the slash script. So your cursor is somewhere in between them. And then we're going to write our first computer instruction. We're going to write console.log, an open parentheses, a double quote, and then hello from the web page. Another double quote, a close parentheses, and a semicolon. I will leave that on the screen while everybody gets caught up. All this computer instruction does is send something to this console. When you click run, you'll all see it. I'm going to click run. And notice on the right here, it said, hello from the web page. I'm going to give everybody about 10 or 15 seconds to catch up and be able to do the same thing. Now, a lot of you may have noticed all this horrific red over on the right in the console. Don't worry about that. That's actually some sort of errors with the actual web page, not the part we're doing, just with the web page itself. They're not going to affect anything that we do tonight. But there you have your first computer instruction. Even though it doesn't affect the web page that people are seeing, you did successfully tell the computer to send some information into a place that you can interact with, namely this console over here, which is pretty cool. All right, so that isn't a program though. That's just one simple little message you put out. So now let's start to actually write some computer code that demonstrates these 5 fundamental elements of a computer program. This is a lot of fun. So the first thing we're going to look at is this. I'm going to take some comments from my own version of this and paste them in here. Do not attempt to type anything I'm about to type. This is not for you. This is just to give you some helpful information for context. I have put in here what are called comments. Comments are things you write in a computer program that do not actually get performed by the computer. They're not instructions. They're basically messages to yourself and to anybody else who's working on your computer program to kind of explain where your head was at, what's going on with the code. I put this comment or series of comments in here just so that we can all have at the front of our minds these 5 basic elements that we care about: entrance point, variables, control and branching instructions, subprograms, and exit point. Now, still not an instruction. So let's do our first instruction. This part, I do want you to enter. Put your cursor after all of these comments, and let's do a console.log and put this is the first instruction of our game program with an exclamation point. That'd be nice. End it with a double quote, an end parentheses, and a semicolon. I'll leave that up there for a moment. And if you want to, when you're done, go ahead and run it. You should see that message appear over in your log in the developer tools. Now, part of the reason I'm putting this in here, especially with my comments, is I want you to see that even though there's a bunch of content in our program, and by the way, our program is everything between this script tag and the ending script tag. All of this is our program. We got a bunch of stuff here, though, that is not an instruction. I told you, it's just comments. This line right here that I'm highlighting, that's the actual entrance point to our computer program. It's the first thing that actually gets executed. All right, so hopefully you've actually successfully executed this and you got something to appear on the console. It's not much different than what I had you do before. And honestly, the entrance point isn't the biggest deal in the world. It's just the first instruction that gets executed. Although, in a few minutes, I'm going to show you how that can be super important and how you can use it to track down what's actually going on in a computer program. So, we've got an entrance point. Fine. Now let's look at variables. So go down below this console.log and let's do a different one. We're going to make a variable. This variable, we use an instruction in JavaScript called var. That's how you make a variable. Let's see if this will work. Hey, I made it bigger. Thank you so much. So put my cursor back there. Var is how you create one of these variables. You say var, and then you say the name of the variable. We're going to have a variable called first name. And now we need to give it some data that's stored in the variable. So use an equals sign, and that is used to give it some data. Put your name here. I'm going to put Eric. You put your name, and then do a semicolon. So we've made a variable. Now let's use it to show you that it worked. The next instruction line is going to be a console.log. And pay very close attention here. We're going to say, hello, a comma, pay attention, a space, and then double quote. Don't do anything else yet. Now we want to use our variable. So instead of specifying the text that's going to go into our console, we're going to use our variable. So we do a plus symbol and then use our variable. Make sure you spell everything exactly the way I am. Then you do a plus symbol, and let's end off with some more text. We'll end off with a period, a space. We'll say, welcome to the snake game. And we'll do another double quote, an end parentheses, and a semicolon. So I'm going to leave that on there for a moment to let everybody get caught up, and then I'm going to teach you a couple more cool things. By the way, when you're done typing it in, hit run, and you should see over in the console, like I have, hello, Eric. Well, you should have your name. Hello, so-and-so. Welcome to the snake game. Now, many of you may have noticed that I'm ending every line with this thing called a semicolon. In lots of computer programming languages, the semicolon is there to tell the computer, hey, I'm done giving you the current command. Everything after this is a new command, a new instruction. That's what a semicolon means in many different computer programming languages. And by the way, if you fall behind with writing all this code, don't worry about it. Just continue watching and learning. You're going to get a full copy of all the code when we're done, so you can be able to understand it, play around with it, play the game. What's more important is learning these concepts. All right. So, excellent. Okay, good. So, we've successfully used a variable. By the way, go in here and change it to something else. Instead of your name, choose John. Then run it again. Now it says, hello, John. Welcome to the snake game. We've successfully created a thing, in this case, the variable called first name, where the data it represents can change as the computer program works. And that's kind of valuable. We're going to see some value there even more later on. So we've covered an entrance point. We've covered variables. Now let's cover some control and branching instructions. This is a lot of fun. What we're going to do here, I'm going to hit enter a few times, give myself some room here. I just want a lot of room so y'all can see what I'm doing here. So, control and branching instructions. What we're going to do is we are going to create of items that represent individual spaces in our snake game where there may or may not be a fruit. That little green dot that the snake was trying to catch is a fruit. It eats the fruit and it gets bigger. We want to be able to figure out whether or not a given position on the game board contains a fruit or doesn't contain a fruit. I'm sure you can see how that would be valuable in this game called Snake. In fact, when we find that a location does in fact have the fruit, that gives us a decision to make. If the snake has arrived at a spot on the game board that has a fruit, we've got some things to do. We have to, first of all, well, most important, we have to add one item to the length of our snake. That's how it works. The snake gets bigger and bigger the more fruit it works, or more fruit it eats. So let's write some code that shows what that might look like and also teaches you control and branching statements. The first thing we're going to do is we're going to make another variable that represents what data might be in a single row of our game board. So we'll call this game row. That's our variable. Here's what it's going to be equal to. Give yourself an equal sign. It's a collection of numbers. And I'll explain why. So you give yourself an open square bracket. You usually find that right above the enter key on your keyboard. An open square bracket. And now, this part's pretty important. We're going to do 0, 0, 0, 0, 0, 0. That's 5 zeros, followed by commas. Then we're going to do a 1, followed by 3 more 0 commas. 0, 0, and then end with a 0, but no comma. Then give yourself a closing square bracket. It's right near the opening square bracket. And a semicolon. Here's what this represents. Let's say you have a row that is 9 cells across, 9 spots across. The 6th spot in the row happens to have the fruit. That's what the 1 represents. Every other spot in the row that our snake could check is empty. There's no fruit there. We're using the 1 to represent, yes, there is a fruit at this exact spot. That's what this collection of data means. So we've got this variable called game row. It represents the data for one complete row in our game board. Great. But now we want to be able to find whether or not a fruit is inside this collection of data. Here's how we do that. We're going to start with the very first element in this collection. This is a collection of elements. Each item separated by a comma is called an element. So this is a collection of elements. By the way, this type of data you're looking at is called an array. An array is a collection of elements. When you have a collection of elements like this in a computer program, you can actually write some code, which we're going to do, it's fun, that will go through each element in turn, and we want to check whether or not there's a 1 there. If there is a 1, we want to make our snake bigger. If there isn't a 1, we don't want to make our snake bigger. I hope that makes sense. So let's write that. We're going to write code that will go through each element of this variable called game row one at a time. You do that by writing the instruction for, giving yourself an open parentheses, and now just follow along. I'll have you write the whole thing out, and then I'll explain what it does. Var index equals 0. Now I need equals, and then a semicolon. Index less than. You'll find the less than character usually just to the left of the shift key, a couple 3 spaces. Index less than, and spell this exactly right. Make sure you get all the capitals and non-capitals exactly right. Game row dot length. That's one where it's super important to get it spelled exactly right. Then a semicolon after that. And then index again. And without hitting the space bar at all, just do plus plus. That's 2 pluses. Then do an end parentheses and a semicolon. I will leave that on the screen for a moment, and then I'll explain what it is. Actually, no semicolon. I apologize. So again, I'll leave that on the screen. All right, now to help explain this, I need you to add two more things. Right at the end of the line, after a space, do an open curly bracket. It's right above the enter key. You have to use shift to get to it. Then hit enter a couple of times and then do a closing curly bracket. You can see that on the screen. Now, here's what this code does. We are going to add some instructions in between the opening curly bracket or the closing curly bracket. Sometimes they're called curly braces. We're going to add some code right in this area, right in here where my cursor is. We are going to perform that code, that instruction, over and over again until a specific condition is met. This part of what we wrote is when we will stop running the code that we're about to write. Again, we're going to write some code in between these curly braces. This line tells the computer how long to keep repeating this action. We do it until the variable called index, because look, we made a variable called index. We do this until the variable, as long as the variable called index is less than the length of our other variable called game row. Now let's talk about that for a second. If game row, this variable, is a collection of items, its length is, how many items are there? Well, we counted them. 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 items in there. So the length of the game row variable is 9. In other words, the code we're about to write right in here, in between the curly braces, we will repeat that code until index hits 9 or greater. And the final thing inside this whole instruction is every time we get done running the code in between the curly braces, we are going to add 1 to this variable called index. That's what plus plus means. It's a bit of computer programming shorthand for increase the value by 1. So we start with index being equal to 0, and we do what's inside these curly braces. Again, we haven't written that yet. We're about to. So we perform what's inside the curly braces once, and then we add 1 to the value of index. So suddenly index goes from 0 to 1. And then we do these instructions again. Then it becomes 2, and we do the instructions again, so on and so forth until index is 9. Well, at that point, 9 is not less than 9. This condition is no longer true, so we don't continue to repeat what's inside the curly braces, and instead, the computer program goes on to whatever else we're going to write afterwards. So I hope that helped explain what we're going to do. It'll become a little more clear once we actually write the instructions in between the curly braces. So just for readability's sake, I want you to put your cursor right on that empty line and hit the tab key once. It just makes it easier to read the instructions underneath, inside these curly braces. So what are we going to do here? Well, we are going to, one at a time, go through this game row variable and look at each element in it and see whether or not it's equal to 1. Because when it's equal to 1, we found our piece of fruit. Happy day. That's fantastic. If not, we didn't find our piece of fruit. So let's go ahead and figure out how we could do that. I'm going to write out the code, and then I'll explain it. You guys copy along with me. If, open parentheses, game row, square bracket, opening square bracket, and then type index, and then end square bracket, 2 equals signs, and then the number 0, and then a closed parentheses, hit the space bar, and give me another one of those opening curly braces, hit enter twice, and a closing curly brace. So I'll wait until everybody does that. Again, pay very close attention to what I wrote on the screen and type it exactly the way I typed it. Now, let's step back for a moment. Remember that of the 5 elements of a computer program, the one we're studying right now is control and branching statements. This is how you get a computer program to make decisions. So we're going to force it to make a decision by checking whether or not the current element that we're looking at is equal to 0. If it is, then we do whatever code is in between the curly braces. If it's not equal to 0, then we do the next instruction, which we haven't written yet, but we will. So let's break this down a little more. So everything in between this open and closed parentheses, we're checking to see whether or not this thing we wrote here is true. If it is true, then we do what's inside the curly brackets. If it isn't true, then we don't do it. So what is all this stuff in between these parentheses? The best way to understand this is to think about the very first time we actually run this line of code. The very first time this line of code is executed or run, index is equal to 0. This variable called index is equal to 0. So let's look at this variable called game row. Game row is a collection of items, or an array is what it's called in programming. So game row is an array. If you want to access one element in an array, the way you do it is you write the name of the array and then square brackets. And then inside the square brackets, you put a number that indicates what position inside that array you're trying to access. By the way, these positions are numbered. You can't see it. It's just part of the language, part of the JavaScript language. And they are numbered as follows. I know this is going to seem weird. You see this first element? It is at position number 0. We also call it index number 0. This one is at index number 1. This is at index number 2 and 3 and 4 and 5. In other words, when you have a collection of items, you start numbering their position at 0 instead of 1. Don't ask me why. You'll learn all about that on the boot camp. It's a long story. But again, like I said, if we're going to try to figure out what everything in between these open and closed parentheses is all about, we've got to consider the first time that this instruction gets run, what are the values here? Well, we know that index is 0. That means we're trying to access the element inside this variable called game row that is at position 0. In other words, this one. So you tell me, the first time we run this, is this data going to be equal to 0? It absolutely is. The element inside this array that's at index number 0, the value of it happens to be 0. So that means we are going to do what's inside this array. What's inside these curly brackets. So what do we do if we have not found the fruit? Well, there's a bunch of complicated logic you're going to look at in the full game. But for now, let's just print out console.log. No fruit at position, do a space, double quotes, and then we'll list out what position in that game row we just checked out. We just checked out the first one, the 0 one. Again, they're numbered starting at 0. Now do a closing parentheses and a semicolon. Okay, good. So I'm going to leave that up there for a moment. And we're going to run the code. And then we're going to add on to this. So I'm going to leave it there for a minute for people to get caught up. All right, so when you run this, oh, by the way, I'd like everybody to see this just because it can help a lot. I'm going to pull my developer tools up. In your console, there should be a symbol right near it that looks like a stop symbol. You know, the universal circle with a slanting line through it. That means stop. That lets you clear everything in the console. Click on that and watch all these messages go away. You probably want to do that just to make it a little bit cleaner for you. All right. Now, go ahead and run the code. And let's examine what happened here. Again, if you have a bunch of errors and it's not working, don't worry about it. Pay more attention to what I have on the screen. All right. So let's look what happened in the console. Well, the first thing that happened is we printed out, this is the first instruction. Why? Because that was the first instruction in our program. Then we have, hello, it should say John. Welcome to the snake game. That's because we executed these instructions right here. And finally, it said there's no position at fruit zero, no fruit at position 0, 1, 2, 3, 4. Ooh, look at that. It didn't say no fruit at position 5, but it said nothing at 6, nothing at 7, and nothing 8. So I want you to look at this code and tell me why it didn't say anything about position 5. It's because when we were examining the element at position 5, remember we number these starting at 0. So 0, 1, 2, 3, 4, 5. When we were examining that element, it wasn't equal to 0. So we didn't do this instruction. This is the first point where we made a decision in our computer program, but we didn't tell the computer what to do in that event. We have a condition right inside these open and closed parentheses. There's a condition to check here. Is the item we're looking at equal to 0? In every previous time, it was equal to 0, but then it suddenly wasn't, and we didn't tell it what to do. So now let's tell it what to do. Go to the end of, like right after this curly brace, right here, the one just below the console.log, go right there, put your cursor there, hit enter, and now use the instruction else, hit a space, and then an open curly bracket, hit enter twice, and a closed curly bracket. Notice this is starting to read like English. If else is a pretty common concept in every spoken language. It should be pretty clear right now that if we don't execute what's in here, then we're going to execute what we're about to put in here. Why? Because the exact item we were checking was not equal to 0. Well, if it wasn't equal to 0, that means it was a 1, and that means we found the fruit. So tab over, like I just did, just for formatting purposes, tab over. And then let's just use a console.log and put in fruit found at position, hit a space, end quotes, and make sure you're using double quotes. And then do a plus, and let's use our index, because that's the item, that's the place in the collection we just checked. The index. And I just kind of I like having a nice exclamation point at the end because we found the fruit. So do another plus to add on some more text, and do a double quote, an exclamation point, another quote. Now end it all off with a parentheses and give yourself a semicolon. I'll leave that on there for you all to get caught up. And when you're done, go ahead and run it. Now, this may or may not appear to be simple code. The fact is, it's demonstrating one of the most important elements of computer programming, which is that we make computer programs very often to automate something we would do manually. In other words, we tell it to make decisions, and based on the decision, we will execute one of two or more different paths. It's like you're at a fork in the road. Here, we've only got two different paths. We have the path in between these curly brackets. That's a path. And we have the path in between these curly brackets. But we successfully wrote a computer program that could make a decision based on the criteria that we care about. Did the snake find a fruit? Now, yes, in the real game, you'd do a lot more than this when you finally found the fruit. You'd have to make the snake longer. But right now, rather than adding in all that complexity, I just want you to see that you're able to control a decision between two or more different paths. Okay, good. So, last part, and this is actually one of the funnest things, is we talked about subprograms. So let me ask you this. We're going to check more than just one row of data, aren't we? In fact, as the game is going, we're going to have to check all the rows in our playing field from top to bottom super fast. Every single time the snake moves, we need to check all of the rows to see whether or not the snake has found a fruit. So I don't know about you, but I don't want to have this code right here. I don't have to write it over and over and over again every single time I need to check a row of data. So why not take this process that we wrote to check a row of data and turn it into a subprogram? I'll show you how to do that. In JavaScript and in many other computer programming languages, the word for a subprogram is a function. So we're going to make a function by typing out function. You're going to give the function a name. Let's call it, now this is capitalized at the beginning, check row for fruit. I'll leave that there for a moment if you get caught up. Now, when you make one of these subprograms, you can give it information that it needs to do its job. What it needs is all the data about a single row. So in parentheses, we're going to pass in a variable called row data. Now, when we call this function, and calling just means asking for it to be performed. When we ask for this function to be performed, well, what are the instructions to be done? First of all, give me an open brace, hit enter a couple of times, and do a closed brace. All of the code to be executed goes right in here. Well, we know what we're going to do. We're going to do all of this. We already figured it out. We know what to do. So let's type that out. We'll say for var index. Don't copy and paste it from above. Equals 0. Index less than row data dot length index plus plus. Leave it there for a minute for people to get caught up. Then you give yourself an opening curly bracket, hit enter a couple times, and a close curly bracket. Now let's check our if statement. Row data at position index equals 0. Give yourself an open curly brace, enter a couple of times, and a closing curly brace. And do the same thing we did before. Console.log, no fruit at position leave that there for a minute for you to get caught up. I know I just typed a lot, so I'm just going to pause for a second if people get caught up. Now we can do our else. Like that. And it's the same thing. We're going to type to the console. Fruit found at position, and then we do index. And then we do an exclamation point. All right, so this is our function. And we are going to learn a lot of really cool stuff. And by the way, we're getting very close to the end of this code writing portion. We're on the final message here, the final learning. And then we're going to do going through the full program, and you're going to run it and play with the Snake program and be really cool because you'll be able to understand so much more of what the code is for the Snake program. All right, so something really important here. I want you to run your program. I'm going to run mine right now. The thing I want you to notice is that the output over in the console log, or in the console, the output is no different than it was before. The code we just wrote didn't change anything about the behavior of our program. We just wrote this whole thing right here, and it didn't make any change in what our program is doing. This next concept is super vital to understanding computer programming. The reason it didn't change anything when we created this function called check row for fruit is that all we defined is potential behavior that will occur when we ask it to occur. We never asked for it to occur yet. A function or a subprogram is basically saying, hey, listen, here's this set of instructions. In our case, here's the set of instructions. A function is saying, here's a set of instructions that when some other part of the program needs those instructions to occur, then we ask it to do its job. That's what a function is for. But we've not yet asked it to do its job. So let's do that. Let's go down to the bottom here, past all your curly braces, and let's make up 3 different fake rows of data. We're going to make 3 different variables that represent 3 different rows of data. We'll call this row 1, and it will be equal to, give yourself that square bracket, and this is all zeros, 9 zeros. 0, 0, 0, 0, 0, 0, 0, 0. Is that 9? 1, 2, 3, 0. That's 9 zeros. Okay, good. and then a semicolon. In other words, the fruit isn't in that row. Let's make another variable called row 2. If I can learn how to spell the word row. And it is going to be equal to almost all zeros, except right near the end, we're going to put a 1, because that's where we have the fruit. 0, 0, 0, 0, 0, 0, and then a 1, and then 2 more zeros. So that's where our fruit is. Now, here's the only point where you can copy and paste. Copy the first row, go down and paste it, but make this variable called row 3. So what you can see here, it almost visually is easier to see as like a playing grid. It's a bunch of spots or spaces on a playing grid, only one of which has a piece of fruit in it. So let's say that this represents 3 of the rows on our playing grid. I just don't want to take a bunch of time and create 30 different rows. But here's some rows. And one of these rows happens to contain our fruit. Excellent. Well, now we don't have to type out this code 3 separate times. One for row 1, one for row 2, and one for row 3. We can do it once for each row like this. Just to make it easy, let's do a console.log and say, hey, we are checking row 1 for fruit. And let's do that. How? I said earlier that when you need to use one of these functions, you can do what's called quote unquote calling it. You can ask for the function to be executed. You do that by simply typing the name of the function. So we will do check row for fruit. Remember to spell it exactly the way you did up above. But when you ask for the function to be executed, we need to give it the information it needs to do its job. In this case, the information it needs to do its job is the row 1 variable that we created. Now you can go ahead and run this, and we'll talk a little bit about what it's doing. Look over here on the right. At this output in the console, checking row 1 for fruit, and then it went through and it said there's no fruit in any of these positions. 0, 1, 2, 3, 4, 5, 6, 7, 8. We expected that because we don't have any fruit in this collection. We don't have a 1. Well, let's check the next row. Let's do check row for fruit. But let's pass in, that's what it's called, giving it the data the function needs is called passing in the data. Let's pass in the variable called row 2. Now run this bad boy. And suddenly, right there at the end, you see fruit found at position 6. We did it. Now, just for completeness, and then we'll have one last teaching moment. Just for completeness, check row 3. Let's run that. Okay, now I want to show you one last benefit to creating these things called functions or subprograms. Let's say we want to change the message that occurs when we finally find a fruit. Let's say we think it's so important it needs to have 3 exclamation points. Well, if we had written out this code 3 separate times for each of the rows, we'd have to make 3 separate changes to have multiple exclamation points. But now, and I want you all to make this change, you can go to the function we made called check row for fruit, go to the else section, and just add in 2 more exclamation points. Go ahead and do that and run your code. And notice it worked. So that means when you have a certain set of behavior that you're going to need at several different places in your program, you put it into a function. And then if you find a way to make that function better, or you need to make changes to that function, you only have to change it in one place. That is called code reuse. The other way we describe that in the engineering world is under a principle called DRY, D-R-Y, which means don't repeat yourself. This is one last insight into how computer programmers think. If we need to do something more than one time, if it's the exact same thing and we need to do it more than one time, we will endeavor to find a way to repeat the process automatically instead of having to do it manually over and over again. All right, so those are our simple code examples to illustrate the entrance point, the first instruction that gets executed, variables, pieces of data that can change as the computer program runs, control and branching instructions, ways to decide whether or not to execute one set of instructions or another set of instructions based on certain conditions. And finally, subprograms, collections of instructions that you can call upon as needed throughout the rest of your program. And here's an example of us calling upon that as needed. So we're not done yet. We're going to look at the snake game, but I hope that helped you to understand a little of the fundamentals of computer programming. So now I want to give all of you the actual code for this full snake program, and we'll look at it a little bit, and then we'll be close to ending off. So Regina, can you share that link? Yeah, everybody go ahead and grab that link inside of the chat. You should see this, a huge chunk of code. Copy all of it. Go back to your editor, and then select everything in the editor and just replace it with that code. When you're done with that, go ahead and run it. If you've done the copy and paste correctly, you should have, and by the way, you can close your developer tools if you want to. We're not going to look at that right now. You should have the playing field. In order to play the game, you have to click on the playing field so that your computer has focus on the playing field. And then you can use your arrow keys to try to get the fruit with your snake. Like that. Whew. It's not actually that easy. So play this for a couple minutes. Okay. All right, good. So let's look at a couple of elements of this computer program. And now you have the full code, okay? And you're free to look through it at your leisure, change things with it, tweak it, and have fun with it. But let's find examples of each of these 5 elements inside this code. First of all, the very first instruction to be performed, the entrance point. Well, if you recall, everything inside the script tags is our code. And you can see the very first computer program, or sorry, instruction to be run. without getting all nerdy and complex, what this instruction does is it finds something on the web page that has an ID called game canvas. And if you look up above in the HTML, where is it? We have an item on the web page with an ID of game canvas. So that's what this instruction does. Is it accesses the element on the web page called game canvas. Now, you're going to learn all about that kind of stuff on one of our boot camps, because pretty much everything on the boot camp teaches you about web development, all of our boot camps, okay? But at least you know what the first instruction is, because you can start at the top and go down, and that can help you start to understand what the computer program does. Second thing, variables. Well, here's a variable. It says setting up game variables. We have the scale of the game. We have rows. Okay, so, and then we have columns. This is some instruction here to create variables relative to the size of the game board. Okay, good. We have control and branching statements. Let's go down here. And look at that. There's some ifs. This is some logic that'll let the snake, watch the snake on my screen. Notice when it reaches the end, boom, it comes around to the other side. That's what this logic right here does. Is it says, hey, if we've reached the limit on one side, have the snake reappear on the other side. That's all this is, but we're controlling it, the path of execution. And then finally, subprograms. Go up to the top here. We have a function called setup, which initializes the game board. It makes a snake. It places a fruit on the board. And then it runs through the game. It draws the fruit. It updates the snake. Again, you can dive in detail into what all these things do, but it should be enough for you to at least know, oh, I have a function called setup. Okay, I know that that's going to be repeated. I also have a function down here called snake. Oh, this creates the snake. And you can follow through, and you know that snake will be used in multiple places. Okay, good. So if it's not running, then there's a couple things that, because I got a message it's not running from someone. Make sure, first of all, that you've deleted all of the existing code before you paste it in. Make sure you've actually selected all the code from that link before you paste it in. And finally, when we get to the Q&A, if there's some specific errors that we can take up, I'll help you with that. Otherwise, there's an opportunity at the end to fill out our contact form, and you can actually send in questions along there. And I'm a nerd. I love this stuff. I'll respond to you if you send in some deeply technical, nerdy thing and try to give you my best answer. All right. So there we have it. Like the full game. You've got this code. It's there for you to go through and tweak and have fun with. For example, I would advise, if you're really trying to like learn how all this stuff works, find out how to make the snake move faster or slower. See if you can do that. Find a way to make it so that when the snake eats a piece of fruit, that it adds 2 to its length instead of just 1. Little challenges like that can help you start to really understand the code, but you should be able to go through it and at least understand the 5 basic elements that are there. Entrance point, variables, control and branching statements, functions, subprograms. And the exit point, by the way, is when you turn off the browser window. That just tells the whole thing it's done. All right. I know that was a lot. And I thank you guys so much for this. I want to make sure I'm not forgetting anything on this code. So give me just a moment. Okay, good. So I would go through and explain every single block here, but there's a lot going on. So basic thing we're doing is we're setting up the playing field and where the position of the snake is and the fruit, right? We are creating the loop that repeats over and over again to control where the snake is and see whether or not we collided with the end of the tail and whether we found the fruit, right? That's what this whole function in here does. Then we have a function that listens. In other words, it's waiting for you to press the arrow keys, and It'll control the direction of the snake based on those arrow keys. We have a function that creates the snake and defines how it will actually behave. In there, by the way, is what to do when we've changed the direction of the snake. There's functions in here for what to do if we eat the fruit, functions for what to do if we actually collide with the tail, with the end of the tail, functions here to set up the fruit itself, where it is randomly on the board. You can see here we're using some random functions to be able to position the fruit on the board. And that's what you have in this computer program. Okay. All right. So let me go ahead and stop sharing this. So we've gone over quite a bit, which is fantastic, right? So I don't have time for a bunch of Q&A, but like I said earlier, I really do want to answer any nerdy technical questions you have. There's going to be an opportunity here in a moment to get a free gift, and I'll give you a way to send in those technical questions when you get your free gift. All right, so quick word to begin about who we are and what we do. We have 12 different boot camps available. You can see the offerings here on the screen. Each one of these is designed to turn you into a well-rounded entry-level technology professional in that area, whether it's cybersecurity, game development, artificial intelligence, mobile app development. Every single one of these is tried and true, tested, been out in the marketplace for years, and they're very effective. A couple quick things about this. Our boot camps, as I said earlier, are self-paced, which means you don't have to move in lockstep with every other student. A lot of training that you do and study, you have to move along with every other person in the class. You don't have to do that on our programs. You can move at your own pace. You can set your own schedule. You don't have to wait until everybody starts and then start in that given week. In fact, you can usually start within 1 day of enrolling, right? They're very well-rounded. We set out from the very beginning to make it so that you didn't just learn some flash in the pan technology that was needed in the industry at that time, but much more importantly, to learn your foundation of being a developer so well that your career was set up well and you have a long-term success path in front of you. I already mentioned that they're quite affordable. We have, we're priced under the national average, right? And we have several different options to help with tuition. The boot camps also, and this is super important, they include job placement training and assistance. Our job placement workers are incredible. They are so dedicated to helping you figure out how to get a job. Because while there are a lot of technology jobs available, the techniques of how to get that first job as a brand new boot camp graduate, they're very specialized, and we're experts in that to help you land that first job. And most importantly, our boot camps are designed for absolute beginners. You don't have to have any prior technology knowledge, coding knowledge, or experience in order to succeed. In fact, you don't have to have a bunch of specialized math skills. That's a lie about the computer programming industry, by the way. You don't need a bunch of math skills. If you can read, write, and do basic arithmetic, you can do just fine getting out through our programs and being a developer. And who are these programs for? Well, they're for anyone seeking a better career. Technology is a fantastic industry to work in. And cool thing, there's lots of remote opportunities available now, lots more than there were before COVID. I will tell you that, right? And tech jobs have a really good work-life balance. You get paid well without having to work, billions of hours every week. It's actually really, really cool. So a couple last notes. These are some of the rewards we've gotten, and we get these every year by all the major rating organizations there are in the bootcamp industry. The bootcamp industry is really mature now, so there's a lot of organizations out there that pay very close attention and provide objective reviews of all the various schools, and we always make the top coding bootcamp lists, and we're very proud of that. You can see that reflected in our reviews. There's lots of different platforms here. We have an average 4.8 stars across all of these platforms with, at this point, over 1,000 reviews. So our graduates are very happy with us, which is very, very cool. If you are interested in finding out more about how boot camps work and how our programs work specifically, you can get a free coding bootcamp guide. It isn't Contact, it's Eric. I'll fix that, right? In fact, let's fix that right now because I believe in handling things immediately. That's the link. Let's do the slideshow again. Go to that link. It's in chat. And if you are at all interested in finding out more, there's no obligation. And the bootcamp guide is very, very helpful. So I'll pause for a moment for you to click on that and fill in the contact form. By the way, if you go to that link and it pops up a login screen, that just means you've already previously gotten an account at the Tech Academy, and you can see the password to use to enter in if you happen to have forgotten it. Anyway, I'll give you a moment here. Stick around because that free gift is coming. And again, it's very cool. All right. So we mentioned a free gift. This one's really cool. Jack and I wrote a series of learn to code books. And probably the one I like the most is the one about JavaScript. We used JavaScript tonight as our coding language. What you'll get is your own copy of Learn Coding Basics in Hours with JavaScript. This book is, obviously I'm biased, but we put everything we could into this book to make it as simple to understand and easy to implement as possible. It goes into a lot more detail than what we could cover in this hour-and-a-half class. And you can have your own copy of it for free just by sending in your name and address to books@learncodinganywhere.com. That email is in chat right now, so you can grab it. And if you did have any technical questions about tonight's class, throw them into that email. They'll get forwarded to me, and I'll do my best to respond and help you understand it even more. So I'll give you a moment to fill that email out. All right. So I want to thank you for attending. Okay. Go back up to the actual correct link here. So I want to thank you for attending and let you know that if you enjoyed this event and you want to learn more, we do these kinds of events regularly. And the next one is very, very cool. Our next event, and we're putting the link is right there in chat, is all about artificial intelligence. Unless you've been living under a rock on the moon, you've probably noticed artificial intelligence being pretty popular recently, right? So we're giving a free class on what artificial intelligence is and how to leverage it. That event link will take, that link will take you to that event. You can sign up for it and any of our future classes that have been posted. And we would love to see you there, right? Also, sometimes we get asked, like, are we going to get recordings of this? We do post the recordings of these classes on our free YouTube channel. That link is going into chat in just a moment. Regina, yeah, there it goes, right? That's our video playlist where we put all of our free learning resources from the Tech Academy. And if you go check those out, you'll see all of our previous classes and lots of other stuff. This class will be posted there within about 2 or 3 days, so you can go through it again at your leisure. And we'd love to see you access those. We're just here to help bridge the gap between people and technology to make it easier to understand, control, and hopefully make a living off of. So again, I want to remind you, if you have any questions, you want to find out more, you want to learn about the Tech Academy's programs, use this contact form link that's listed on the screen. And I want to see you at future classes. Please join us. I hope you've enjoyed this. I hope it's helped. I'll stick around if anybody wants to throw anything in the chat for any little questions. But otherwise, that's our class, and I hope you've enjoyed it.